Hi, this is Scott Forbes and welcome back to science class. If you check out today's video, it's dated August 21st, Friday, which is really tomorrow. But it's kind of the last of my kind of free-form introduction videos, hoping you get a feel for the class, what we'll be doing, and why it's important. Today, I want to talk one last thing. Why is science one of our core subjects here? If you look at the subjects that you're asked to take, you have social studies, English, physical education, very, very important. And if you look at the subjects like science, why would that be one of the ones that we have as a core subject here? Why not say economics right now or something else? One of the things that I would argue that is incredibly important in science is the ability to think clearly about subjects and go past opinion or just what your idea is. Quick example, this is an election year, a national election year. And in an election year, people who vote, and that'll be you shortly, are introduced to all kinds of blanket statements. If you vote for this candidate, things will get better. If you vote for this other candidate, no, things will be better with this other candidate. What science does is it lets us distill, it lets us look at the facts, it lets us, in a way, conduct what we call experiments with the facts that we have available and make a rational decision. That's why I love science. One of my very, very favorite scientists of all time, Richard Feynman. Book right here, he has 6 Easy Pieces, and he also has another book, 6 Not So Easy Pieces. You should check it out. Richard Feynman, an amazing scientist, fun to listen to as well. Really quite a character, and if you look at one of my favorite quotes from him, it says, "It doesn't matter how beautiful your theory is, it doesn't matter how smart you are, if it doesn't agree with experiment, it's wrong." It's a perfect statement. In science, it's a perfect reason why science is one of our core subjects. When you do an experiment, really the heart of science, and even though we're starting off with distance learning, there's plenty of experiments we can do that show how you look at the results and you decide, hey, was my idea correct or was it probably not correct? Yesterday I gave the example of baseball. We do a little bit of practicing with baseball. A good experiment, or today we're going to use golf, but a good experiment is really the heart of science. It's really why we're taking this class. It shows you how to set up with variables over across the hall in the math classes. You'll be talking a lot about variables, especially in middle school, X's and Y's, and you'll be graphing them on the coordinate plane. That's why I have up on the wall to my left, which I showed on the previous video, some math posters. Yeah, this is a science class, but science and math go hand in hand. If you look at the variables in experiments, those are the things we're going to start off with because they're so important. They're the little tiny things that can change every single time you perform an experiment. And you can choose to change some of them. Some of them you can't, you try and control them, but sometimes you can't control them so well. Give you a quick example outside and we'll call it a day. And then the next video should be jumping right into the lessons. Put on my glasses so I can see the video screen. And as I walk outside, I'm walking around this way. One of the things I tried to show you, by the way, the other day was the floating giants golf ball, or baseball. We talk a little bit about that because it happens to get to magnetism. Walking outside the room, you can see the basketball court where we were checking out the shadows the other day is in bright sunlight now. Tried to check out this morning where the shadow landed, but it was foggy this morning, as it usually is in the morning in Pacifica. And that's okay. We'll check it out tomorrow or the next day, but not sure if you can see it with this video, but the line is still there. So we'll see if the shadow grew, if the shadow shrank a little bit, got shorter, or if it stayed in the same spot. If I put my camera down very, very quickly, and I'll try and work on production value. Now I would never really hit a golf ball on campus because, that's not allowed. Totally not allowed at the school district. I'm just giving this as an example. But anyway, think about a sport like golf. I use sports as examples quite a bit. In this case right here, you've got a goofy shaped club, you've got a ball, and every time you swing, you see people out there swinging and practicing the golf swing. Why? There's variables. You can kind of think of each swing like an experiment, and if I put the ball down here on the ground, I'm not really going to hit it because that would be totally illegal on campus. Just giving the example. And you swing every single time a club comes through, it might hit the ball in a slightly different angle. You might swing a little faster, a little slower. It might hit it down, or it might hit it scooping up. There's all kinds of different things that can happen. People practice because they're trying to control all those variables. They're trying to make sure that what they did one time happens again exactly the same time the next time they perform their experiment or their swing. Use baseball as an example yesterday, using golf as an example today. We're going to use all kinds of different examples over the course of the year. But the important thing is this. We're doing science class, we're in science class to learn about the method. That book that I showed you the other day, the PDF that you'll get, or if you choose to pick up one of the green books, that's great. It's a fantastic science book. But it's a collection of facts, really. If you memorize every fact in that book, it's wonderful, but that's not science. Science is a process. So if you check out the process, every time you're performing an experiment, you're saying, oh, okay, what were my results of that experiment based on the variables that I changed on this time through. So that's why we're in science class right now, to be able to perform good experiments and to be able to say, okay, I understand the process, and when I'm looking at the results, when I'm looking at anything from cooking to a scientific experiment, to say politics, I know, like, okay, does my result fit with my original idea? Have a great day. Looking forward to jumping in on Monday with the curriculum. And oh wait, I didn't really hit that golf ball. Talk to you later. Bye-bye.